Hello. Today we're gonna be today we are going to be implementing vector in C. So hold on. Vector, let's call it dynamic array in C that uses our custom linear allocator memory. Okay, so I already did the alignment. So .h so vector contains capacity, now count, then the size of the element, since it's a dynamic vector, then the data pointer to store the sequence of elements. Then we have arena. Of the method. So the methods are vec push, pop, vec add. I think we can also implement vec next for the iterating. But first we need to have vec new, destroy. Okay. So okay. We take the element 5, then the allocator. User has to provide the allocator. And then we first check if the allocator is actually not now. Okay. Then we have to create the vector. When unlock, we take the allocator. Okay. Then the size of the type. Okay. So let's see. Actually, not null. Return null. Say unable to allocate vector object, whatever. Then we specify the allocator. Do we have to allocate for the event as well? I don't know. I think we'll see. Since it's actually allocated by the user, we just take the point. But for the data, we have to allocate again. So for the vec element first, take the element first from the user. Vec count, it's gonna be 0 because there's nothing in there. For the data, I think for the data we have to allocate at least some amount of memory. Base count. Okay, let's store the capacity as well. Let's say 10. Capacity. Base capacity. Then for the data, we allocate. Takes the allocator. Then it takes the 5 of base cap. No. 5 of element. Okay. Element 5 multiplied base cap. But if the capacity is full, what do you have to do? I think because then we can expand the arena. We have to create a new arena and use that for the data. But then we have to copy the old data to the new arena, then free the old arena. Let's first try this one. Okay, so check if allocation is okay. If it is no, we have to free the, we don't have to free because user has to free that. So now we were unable to allocate for the data pointer of the vector. So we will return now. Yes, that's it. Right. We are checking if the allocator is no. Then we are allocating for the vector. And we are checking if the vector allocation is okay. The vector allocation is okay. We're storing the allocator in the vector type. We're storing the element size, count, capacity in the data. So initially we're gonna use the base capacity for that. So then we will see how to increase the capacity dynamically. Okay. So I think we should take the base capacity in here as well. It's here. Let's save it for the user. Okay, and we will return the vector. And the next one, extra push, pop, hit. I think you don't have to implement the destroy because the user will actually free the memory in the arena. Let's implement vec push. It's gonna return int. If it's 0, it's success. If it's 1, it failed. Returns 0 if, oh my god, let's take the pointer to vector and then the element. Okay. So now we have to take check if the vector is not known. Okay, then we'll check if element is null as well. And we will data. We don't have to copy, we just have to store the, yeah, data. What is the offset? Make count. Since it's actually 0 initially, it's going to point to the first index. We have to multiply by, don't have to multiply. So we're going to store at the first index. Since it's a void pointer, now it's going to be, let's see, equal to, it's going to work. Yeah, we have to, I think, data is void pointer. Okay, we have to implement the pointer count. Now, size of element. Okay, make element size into count. So it's gonna be 0 initially. What is wrong with the argumenting on a pointer? Okay, this is going to work. Okay, then we have to store the element here. Expression is not assignable. Mem copy, mem set. What do you mean it is not assignable? Not modifiable value. So you have to cast this into. I don't think we have to copy because you only have or maybe we'll copy. And copy. So I think this is the destination. Okay, this is the destination. This is the source and the size. Okay. this name is vec data plus element 5 into count, so it's going to be 0. Okay, yeah, we have to cast things into character pointer. Then the source is element, and 5 is element 5. So we're gonna copy the user passed element to the data. Okay, then we have to increment the count. Okay, but first, before doing everything, all of this, if vec if capacity is equal to count, it's already reached, then we have to return 1 contain vector is full. So user has to create a new vector with more capacity, then copy the whole vector data into this one by iterating and pushing into the new vector. I believe that's it for the push. We have to return the indicator. We will test after this. So we have vec new, vec push. Then we have to check the vec pop. Does mem copy return anything? It's gonna return void pointer. Don't need that. And what is the other function? Vec pop. It's gonna return the status as well. Pop. It's gonna take the pointer to the vector. Then the index. No, pop will pop on the back like the recently pushed element will be popped. So if vec equal null, return 1. Okay, then we'll, I don't think we have to do anything. I just have to decrement the count, right? And we also have to make sure that the user isn't popping to below 0 because type is size t, it's unsigned. So if the user actually pops after the 0, let's see, if the dot count is already 0, he can't push in, he can't pop anymore. There are no elements to pop. Vector is already empty. Nothing to pop. Then if okay, like count decrement by 1. Okay. And then we have to see pop 2. The user can pop multiple items. Now that's going to be the list. So it is done. vec at will actually get the element from the specific index. It's going to return the element. It's going to take the vector pointer. Then it's going to take the index. We have to see if the index is all if it actually exists or not by checking the capacity. If like dot count if as an index, so this is an out of bounds. So user cannot get the element. Okay. Looked out of bound because if the count is less than the index that the user has passed to the method. Now why are we returning more? Then we will element data increment by index into element 5 I think that's it. We are getting the address of the element by taking the index. We are multiplying by the element 5. Then we are returning that element. What are the other functions? Vec next. The vec next will return status and it will take the I think it will just take return the element. It will keep incrementing the internal counter. So for this we have to create an iterator because the iterator contains the internal counter index. Okay. Count. No, let's call it index. And then I think that's it. So how does this work? User has to create a iterator, right? Vec next will take the iterator on the vector and it will use the iterator to maintain the counter, and with the counter it will use the index of the iterator to return the element from the vector. Okay, let's see. It's going to return the element. Like next, it's going to take the vector pointer and the iterator pointer. I think that's it. is j dot index is equal to greater than count. So it will keep incrementing the iterator counter, and for the next time it will recheck the index whether it already exceeds the count of the vector. If it is, it returns now. And not for this. Think what pointer element point vector and F6 the index is yes, then we will return the element. This way user can do then we have the clear. We have to implement the clear. Okay. For the clear, we have to, since we are copying the, I think we just have to clear the array now. Okay, wait. We have to reset the count to 0. Then we have to reset the allocator. Okay. This way we are freeing. We are not freeing. We are just resetting the count of the array now. I think we will test. Okay. Okay, let's create a type. And let's call person. Contain name is gonna contain the, then it's gonna contain location information. Float latitude, name. Okay. Okay. So in this example, we're gonna use we have to create the winner first. Winner. 5, let's say, I think that's 1 MB. Then we have to create the vector equal to can take the element 5 person and I'll take the base capacity. Let's say 10 in the allocator. And we can push. Let's use a for loop. Okay. And then the element. We have to create the element. We're gonna create the element on the stack. Person equal to and for this one, let's create a cache. Okay. So for this, Let's make the age I, so we'll know. I think we need to create another T. It's good. So we keep pushing it. I have to validate if it's not success. It is 1. Something happened. I think we will know because we are already logging in the library. Okay. After pushing, we have to use the vec at to get the, we keep using the same one. At, then we'll print the person age, ID, age, name, attitude, attitude, name, person, ID, person is person, name, person, location, attitude, attitude, usual. Okay. New line. And then we have to use the iterator as well instead of a traditional for loop. While like next, I have to create the iterator. Not equal to null. Will actually return person. Can we do that? Think why? Okay, we're gonna get the I think we have to change the select next. We have to return the int. Okay. Oh no. Let's see. Let's, for example, test this one. We also have to free the okay. Okay, it's working. We are creating the have created it. But let's try to insert more than 10. Yeah. Oh wait. With how is oh why are we getting it at the start? Okay, because we are not printing it. We have to say it's success. If people pushed man's like okay. G in not in there. Okay, we got the vector is full. And let's try, since we created it, we should be able to do it after the clearing. Okay, we got vector is full. Then we actually pushed it. Okay, that's good. Okay, so we created vector as well, but we didn't actually did the iteration. Let's remove this because we don't have to use it. I mean, I won't use it. Yeah, we have memory alignment. Okay, now we'll see you in the next video. I think in the next video we'll try to implement a string helper function. Let's see. And in C# we have where the methods. Okay, I mean string. Okay. So we'll try to implement contain splitting, joining, replacing substring. Then we also try to implement a string builder. And after that we'll implement. So next video we'll implement string, then we'll decide what to implement next. Okay.